another proof and a couple more hints. This guy truly is elegant and quite beautiful, and it isn't quite intuitive that you go, oh yeah, I see what to do. Let me give you a little bit of hint about it. So first let's tell you what we want to do. This line is an angle bisector, and the claim is that we should be able to prove that the ratio of AD to DC, those two, the proportion, the ratio between those two should give us the same as the ratio of those two. Quite unique, actually. But how do we do this? Well, here's the good news. The proof right before this one helps us out quite a bit. It's a huge shortcut. But to get to there, we have to pull a little trick. That's why this guy's a little bit nasty, but it's fun. Here's what you'd need to do first. You need to introduce a brand new line to BD that is parallel to BD through A. So what it would look like is something like this. And we would extend this out to meet at, I don't know, I think we call it point E. Yeah. Now, what are we doing? Well, here's the idea. You and I, in the proof right before this one, established that when you have parallel lines, these two guys, that this is to this, as this is to this. Now that is pretty darn close to what we want, isn't it? Look, AD to DC we got, but it says EB is to BC. So the only thing that we are missing right now using the previous relationship is somehow I need to show that EB and AB are the same. I can make a substitution there and then I would have it. Now here's the fun. These parallel lines introduce some angle relationships. This angle would correspond with this. Because they're parallel, this angle would be alternate interior to this. Guess what? We have an isosceles triangle where EB is exactly equal to AB. A quick recap of this. This guy's got a bunch to it, and I know you're writing quickly to get it all figured out. Here's what I did. I extended a new auxiliary line parallel to BD. In doing so, I was able to form the relationship of proportional pieces, the proof I just did, the side-splitting theorem. And once I introduce that, I can now say this is to this as this is to this, which is very close. The only thing I'm missing is I want to say AB is to BC. And using some recognition of the parallel lines and the angles, I'm able to prove an isosceles, which proves two equal sides, and then a nice little substitution. It's easier said than written, but good luck. There's some help for you.